This application of integration really focuses on the units involved. So I'm calling this mass from density. What I want to think about here is that an integral doesn't always have to just represent area and context. Depending on what the function is measuring, it can really represent all kinds of things. So what we want to consider here is, for one thing, the units. When we think about an integral, because we have the integral is coming from a limit of a sum, but in particular, the terms of that sum are each involve a product. So if you think about what we're adding up here, then we know that these involve the output units, and the delta x is dealing with the input, so that's going to involve the input units. So when we're talking about a derivative, the units typically become the output units divided by the input units. And again, that comes back from thinking of the difference quotient as a ratio. But instead, with an integral, we are actually multiplying the output units and the input units. So if we think about now that, suppose we interpret that the interval from A to B is an object of length B minus A. And on top of that, at every point in that interval, so let's call that point x, the function f of x measures the density, let's try writing that again, the density of the object at point x. Then in that case, the units of the integral, so if we think about here, first of all, the units of, not the integral, let's just say, of f of x, if it's measuring the density, we can think of that as whatever the mass units are divided by the length units. So consequently, if we then think of the integral from A to B of this density function, this represents the mass of that object of length B minus A. And by the above discussion, we could see that the units of f are, as we found here. If I multiply that by the units of x, the length units, then the result is just units involving mass. So this is all a little bit removed here, but just to kind of think about this, you could think, what if, just some examples of units, if the units of f of x could be, say, kilograms per meter, then you could see that I could use an integral of f of x that would result in giving me the kilograms. So the length units here are in meters. We could have something involving, say, temperature. So maybe f of x is measuring the temperature here per meter. So that if I were going to integrate such a function, then again, thinking about the input units being meters, then the integral would give me the units of just temperature. And here maybe more of an economic example, if f of x is now measuring, let's say, dollars per meter, then the resulting definite integral here would just give us the price, the total dollars. So in the next video, I will look at some specific examples with context, but the main thing I do want to carry through with this is to really pay attention to the units in that context, and consequently thinking of what the integral really gives us.